upright 30 meters from the lens, find the magnification of the image, find the height of the image, find whether it's real or virtual. So it sounds like a lot, but it's just two equations. It's just these two equations here. Okay? So first thing we're going to do is we're going to do A. So converging lens has a focal length of 10. So F is 10. Image of an antelope, so we're looking for DI. 30 meters away from the lens, so that's DO. So we're looking for where does it show up if we put it 30 meters away. Okay. The equation is 1 over F equals 1 over DI plus 1 over DO. I think I wrote it DO plus DI. It doesn't matter. The order you add them in doesn't matter. Okay? So, plug the numbers in. F is 10. All right. There's two ways to solve this. You can either do decimals or you can do fractions. I do not like to do decimals. I prefer fractions. Some of you may have taken a solemn vow that after junior high you would never do fractions again. And heaven forbid that I be the one to make you break your solemn vow. So if you want to do decimals, you are totally welcome to do decimals. I think it's harder. You have to do a couple extra steps that you don't have to do if you do fractions. It's up to you, but I'm going to show it to you with fractions. If you want to do decimals and you're having trouble with fractions, let me know and I'll help you. Okay, so first things first, we need to get a common denominator. And to me, the common denominator is got to be 30, right? 30, multiply 10 by 3, and you get 30. So 30 is the common denominator. So I'm going to multiply both sides. Multiply both sides top and bottom by 3. And the reason for that is 3 over 3 is 1. You can always multiply by 1. Okay, so I multiply the top by 3. I'm going to bring this down over here. Multiply the top by 3 to get 3. Multiply the bottom by 3 to get 30 equals 1 over DI plus 1 over 30. I need to get the DI by itself, so I'm going to subtract the 1 over 30 to both sides. When you do subtraction with fractions, you leave the common denominator the same, so it's still over 30. And you just subtract or add the top numbers, so it's 3 minus 1 is 2. And you may be saying to yourself, but Mr. B, I don't want to get a common denominator. I don't know why you sound so whiny, but here's why. Here's why I suggest fractions. You don't want 1 over DI as your answer. You got to have actually DI. If you have it in fractions, here's how you get DI. Whoop. Whoop. 30 over 2 equals DI over 1. Simplify it down. 15 equals DI. There's your answer. Now you can absolutely do this in decimals, but if you're doing in decimals, 1 over 10 is 0.1, 1 over 30 is 0.33. You gotta subtract that over to get 0.67. You would then have to cross multiply. Once you cross multiplied, you would have to then do some division. It's just some extra steps that you don't have to do if you do fractions. So that's my suggestion. All right, A, knocked out. Any questions on A before I go on to B? Sweet. Okay, B. Find the magnification of the image. So I need to know magnification. I already know F, it's 10. I already know DI, it's 15. I already know DO, it's 30. Okay, so the equation is m equals negative di over do equals hi over ho. Nope, that's an h, totally an h. Okay. Okay, it's like the seven dwarfs said for Snow White: "Dido, hi ho, it's off to work we go," or physics we go. Either way, totally pretty sure that's how it goes. So, how do I do this double equal sign business? Here's how you do it. It's really two equations. It's m equals negative di over do, and it's m equals hi over ho. But rather than write two equations that'll confuse you, I just wrote it as one equation. And here's how you do it. You look at what are you solving for, what do you know, what are you trying to find. So I'm trying to find m, so I got to leave m alone. And I have di and do, and I know nothing about hi and ho. So, cross them out. Now you have your equation you're going to solve. So m equals negative di over do negative 1/2. There is no unit for magnification. It's just a number. Just a number. Okay. There's, say again?
Would it still be negative 1/2? Because I mean, you're still like negative 1/2 and half are technically the same.
No, so here's why the negative matters. Is that what you're asking? Why does the negative matter?
Yeah.
So the negative matters because that's how we're going to figure out whether it's virtual or real.
Oh, okay.
So that's why the negative matters. Yeah, that's a good question. All right, C. Magnification, negative 1/2. F, 10. Di, 15. Do, 30. And now it says we have an object that's 2 meters tall. So HO is 2. And what is the image height? So same magnification equation, m equals negative di over do equals hi over ho. I have to use the hi and ho because I'm solving for hi. So I got to keep that around. However, I know di, and I know do, and I know m. So I can use any of the other two that I want to. I find m to be easier because it's one number instead of two. So I'm going to cross out the di, do. And there's the equation, m equals hi over ho. So negative 1/2 equals hi over 2. 2 goes to both sides. And we get hi equals negative 1. Which brings us to D. Determine whether it's real or virtual. Here's how you do it. If the sign of m is positive, it's virtual. If the sign of n is negative, it's real. The sign of m is negative, it's real. That's it. That's all you got to do. That's all you got to do. Just look at the sign of m, figure out if it's positive or negative. That's if it's real or virtual. That's it.